Okay, this is the second video covering section 1.7. Um, so for exercises 1 through 4, they're asking us to decide essentially if the sentence or the statement reflects a function or not, right? So they're calling it either a relation or a function. So it says the input is September 1st. The output is any Brookdale student born on that day, right? So if you think about that, if I had a table and my input was September 1st, right, you might think of this as, right, September 1st, September 1st, September 1st, September 1st, and then maybe Bob has a birthday on September 1st, and Mike has a birthday on September 1st, and Jen, right? At Brookdale, it's very possible, and maybe Fred, it's very possible that, you know, we have, I don't know, 14,000 students. It's possible that 4 of those students or more might have a birthday that falls on September 1st. So the input September 1st might have multiple outputs. So this would not be a function, not a function. So maybe we would just call it a relation. It's a relation that is not a function. All right, number 4. There are 80 calories in 1 chocolate chip cookie. If X cookies are eaten, write a rule that determines how many calories are consumed. So Y is equal to the number of calories consumed. And how do we determine how many calories are consumed? Well, if we know there's 80 in 1 cookie, we can say there's 80 times X cookies, right? So the more cookies I eat, the more calories I consume. For the record, I love chocolate chip cookies with vanilla ice cream on the side. Delicious. Okay, I didn't realize there were 80 calories in a cookie, though. That's scary. So anyway, this is the rule, and this is indeed a function, right? Because for each number of cookies, there's only 1 calorie count, right? If I have 1 cookie, I don't gain 80 calories and 70 calories and 50 calories. 1 cookie is exactly 80 calories. 2 cookies is 160. 3 cookies would be 240 calories, right? So for each number of cookies, there's 1 value for calories. So this is a function. So I'm just going to write, yes, a function. All right. Let's keep moving. It says a graphical representation of a function. So then it says, I complete the table below for practice exercise 4. So that was the cookie problem, right? So remember, if we had 1 cookie, we had 80 calories. 2 cookies would be 160. Whoops, a little sloppy. 3 cookies would be what, 240, right? 3 times 80, right? Remember, you're just putting in the number of cookies for X. And then 4 cookies would be 320. So I'll write the ordered pairs. I'm going to use my typewriter tool for that. So this is the values of my ordered pair. So now if I want to graph that, I can plot the points, right? Oops, get my pencil to work. Right, so 1 comma 80 would be somewhere around here, right? 2 comma 160, right? I'm just kind of eyeballing this. 3 comma 240, and then the last one is 4 cookies, 320. And I don't have a ruler, so I'm going to try to freehand. This is not good. Just pretend that's a straight line going through all the points. Again, if we had a ruler, this would be a little straighter, right? So just pretend that's a straight line. You know what? I realize I have a line tool here. Let me see if I can erase this and actually put in a straight line. Yeah, I think this is a little bit better, right? So again, this table's numeric representation. This table. This is a graphical representation of the cookie problem. Here's a symbolic representation. And the actual words would be a verbal representation of the function. Okay? Let's see. Let's move on to the next page. Sometimes if we have a graph, we can do what's called the vertical line test to see if we have a function. right? And there's a little definition in the yellow box. Maybe take a moment to pause the video and read this definition. But the bottom line is, if I draw a vertical line, if it only intersects my graph one time, we have a function. So you notice I'm drawing these vertical lines through this first picture, and it only intersects my graph one time. So I can say the first one is a function, right? Function. Now the second graph, when I draw my vertical line, notice how it intersects twice, right? There's an intersection, hold on, here and here. It intersects two times every time I draw a vertical line, so that means it's not a function, right? So if I draw a vertical line and it intersects my graph more than once, not a function, right? So these last two, you can see as I draw vertical lines, it's intersecting twice, so not a function, okay? Let's keep going. Function notation. All right, so how do we write this using some type of standard notation? It says the notation y equals f of x. So this is not f times x. This is pronounced y equals f of x. Y is a function of x. Defines a function named f. This is read as y is a function of x, and the letter x represents the input or the independent variable. This is important to kind of memorize here, right? That the x is the input, and it's also called the independent variable, whereas the letter y represents the output or the dependent variable, okay? Just try to remember this. This is a mouthful. So again, maybe you want to turn off the computer or the video for a minute and just kind of think about what's in this yellow box, okay? On the next page, you'll see they make a reference to the practice problem, again with the cookie, right, where we have the rules y equals 80 times x. And they say, well, can we write that using function notation? There's not too much to it. They just replace the y with f of x. So really what you need to know is that y and f of x are the same, okay? So you could write y equals 80x, or you could write f of x equals 80x, okay? These are both saying similar things, right? If I said find f of 2, that means what is the value of calories when I have 2 cookies, right? It would still be 80 times 2, which equals 160. Whoops. Which equals 160. Okay. And then if I ask you what's the value for calories for 2 cookies, right, you could always just write y equals 80 times 2. Right? It's still going to give you 160. So my point is, whether you use y or f of x, the meaning should still be similar. All right, now looking down, they give us a couple of rules. They tell us what type of function we have here, right? Since I have a 2 for my power, it's called a quadratic function, right, degree 2. With a 3, it's called a cubic function, degree 3. If there's a variable in the denominator, we call it a rational function. And if there's a radical sign, right, this looks like the square root symbol, we call it a radical function. And notice the only thing they did between column 1 and 3, they replaced the y, right, they replaced the y with f of x. For all of these, right, they replaced the y with f of x, all right? So let's see. Underneath, we have some practice problems. And remember, the answers to the practice problems can always be found in the back of the book. I think I'm going to stop here before we look at some of the practice problems, and I'll do a third video shortly. Thank you for watching.